All right, this is the solution guide to the types of chemical reaction worksheet. So first thing, let's look at balancing. One sodium atom, I have two iron atoms, and I have three oxygens. On this side, two sodium atoms, one iron atom, and one oxygen atom. Okay, so let's see here. I'm going to leave the sodium and the iron alone for now because they're all by their lonesome. So super easy to balance. Let's look at oxygen. I have three and I have one. So if I flop a three here, that turns this guy into three. Sodium is going to turn into six. Now it's super easy to balance. All I have to do is put a two here to make the iron two, and put a six here to make the sodium six. Okay. Now, what type of reaction is this? Notice I have a lone element and a compound, a new lone element and a new compound. This is a single replacement. You have sodium replacing iron in a compound. That's what single replacement looks like. Okay. Okay, atom inventory. Let's see, two hydrogen, two bromine, one hydrogen, one bromine. Pretty simple to balance. You flop a two there. These both turn into two. You have two things turning into one. That is what synthesis looks like. Two elements combining into one compound, or it could be, two compounds or a compound and an element. But anyway, it's two things becoming one thing is synthesis. All right, let's take a look at this one. We have one silver. We have one chlorine over here. One silver, two chlorine. Okay, I'd put a two here to change the chlorine to two, but it also changes silver to two. Flop a two there, and we're good. So you have one thing falling apart into two or more parts. That is decomposing. Decomposition. All right, let's take a look at this one. Two carbons, six hydrogen, two oxygen. Over here, one carbon. Let's see, two hydrogen, and we have a total of three oxygen. Okay, I'd probably start by flopping a two here, and that's going to make two carbon. Then my oxygen, I get two plus that guy we now have, or excuse me, four plus that guy is five. I'd put a three here to balance the hydrogen, so here is six. Oxygen is three, and those four are now seven. We actually didn't do one like this, but I'm going to kind of give you a hint here what you would need to do. Yeah, because this is one of those goofy ones. I guess I didn't notice that. Just to give you guys kind of a hint, what number times 2 is 7? Well, it's 3.5. But you can't have 3.5, so you got to double everything. This is going to be 7. This is 2. This will be 4, and this will be 6. I won't give you one like this. Okay. If we had more time, we'd do them. But anyway, so don't worry if you couldn't balance this one. This is a combustion, though, because you have a hydrocarbon, and then this part is always the same. O2, CO2, H2O. All right. One calcium, two oxygens, two hydrogen over here. One calcium, two oxygens, two hydrogens. This one is already balanced. Okay, that happens. This is that's not decomp, that's synthesis, my bad. Synthesis because we have two things turning into one. They are synthesizing. Okay, over here, let's see. I have one calcium. Oxygen, I have two. Hydrogen, I have two, plus that guy is three, and I have one chlorine. On this side, I have one calcium, one oxygen, two hydrogen, two chlorine. Calcium looks good. Oxygen, I'd flop a two here. That's going to make oxygen two. Then hydrogen over here turns into four. 3 and 4, you might think, oh, I need to get 12. Let's skip it and do this part, okay? Because this one's going to be a little easier. I've got 1 and 2, so if I flop a 2 here, chlorine becomes 2. Hydrogen is 2 and 2. Oh, that fixed it 4. Okay? So, what this is, believe it or not, this is a double replacement. You have two compounds turning into two new compounds. And check this out. Calcium, the cation of the first goes to the anion of the second. There's your calcium chloride. The cation of the second goes to the anion of the first. Hydrogen goes with the hydroxide, or HOH, or H2O. Double replacement. Okay, let's look at this one. I've got 1 iron. I've got 3 nitrate groups, because notice there's nitrate on the other side. 1 lithium, and then I'm going to leave hydroxide together because it's over here. Okay, products. 1 iron, looks like 1 nitrate. Lithium is 1. Hydroxide is 3. I'd probably start by putting a 3 here to balance the nitrates. That's going to turn my lithium into 3. 3 in front of the lithium. Lithium becomes 3. Hydroxide becomes 3. We're balanced. Okay. This is another double replacement because iron is going with hydroxide, right? Lithium goes with nitrate. So 2 compounds forming 2 new compounds, double replacement. Okay. 1 iron, 2 oxygen over here, 2 iron, 3 oxygen. So let's see. Iron I'm going to leave alone because it's all by its lonesome, super easy to fix. 2 and 3, common factor is going to be 6. Put a 2 here, this changes to 6. This turns to 4. If I put a 3 here, 3 times 2, that is 6. All they need to do then is put a 4 in front of the iron and we're balanced. This is a synthesis. 2 things becoming 1. All right, let's take a look at this one. Okay, this is, let's see, 12 carbons. Hydrogens, I have 22. Oxygens, I have 11 and 2, which is 13. Product side, 1 carbon, 2 hydrogens. Oxygens, I have a total of 3. Okay, I'd probably start by putting a 12 here. Carbon turns to 12. I have 24 plus 1 is 25 oxygens. Not a big deal. Hydrogen, I have 22 and 2. If I put an 11 here, 11 times 2 is 22. Now let's take a look at our oxygen. So we have 24 here plus 11. 24 and 11 is 35. Now at first you look at this, you're like, oh, woe is me. Because 13 and 35, those don't look fun to factor. Okay, but it's not that bad because if you look at it, oxygen appears in 2 places. All right, and so if I'm trying to get 35 oxygens over here on the reactant side, I'm not going to mess with these 11 because if I start putting coefficients in front of here, it's going to screw up both carbon and hydrogen, which we've already balanced. So out of the 35 I need over here as reactants, I'm not going to touch these 11. So that means 35 minus 11. Well, that means I need to come up with 24 from O2. Well, that's not too bad, is it? Because 12 times 2 is 24. 24 and 11 is 35. We're balanced. So sometimes you come into situations where you're like, oh man, this is going to be hard, but it's really not that bad. This happens to be another combustion because you have a hydrocarbon, O2, CO2, H2O. Okay, that thing is burning. All right, let's take a look here. Notice we have nitrate, but this is not nitrate, so we have to separate it as elements. 1 lead, 2 nitrogen, right? And then 6 oxygens. On this side, it looks like 1 lead. Nitrogen appears to be 1. Oxygen, I have 1, 2, 3, 4, 5. Okay. Well, lead looks good. Nitrogen, I have 2 and I have 1. I'd probably start by putting a 2 here. That's going to make this guy 2. Oxygen, here's 4, 5, 6, 7. Honestly, guys, this one was probably a little tricky to do as well. This one, you're not going to have one like this on the exam, just because of our limited time doing this. How you would have solved this is that this would have become a half. Half of O2 is O1, which makes this 6, but everything has to be whole numbers, so you end up doubling everything. So if you don't understand this, that's okay. Okay, I won't give you one like this on the exam, but here is that is balanced if you want to check it. Okay, and 2 leads on each side. There are 4 nitrogens on each side, and there are 12 oxygens. This one is another decomp. Okay, one thing splitting into 2 or more. It doesn't have to be 2. In this case, it's split into 3 things, but it nonetheless decomposed. And that's it.